Okay, here's the answer key to the graph stacking worksheet that you guys did today to help you for your quiz. Alright, let's go right into it. Question 1. We have a graph that looks like this, and it's a slope going up and then a slope going down. Alright, so to describe this motion, always helps to describe this in words to make the rest of it make sense. So we were moving at a constant velocity to the right or in the positive direction. Then, when the dotted line appeared, we're moving in the negative direction at a constant velocity. So, positive velocity and then a negative velocity. We know that because we looked at the slope. Okay, so our motion map will look like this. We started to the right, so we start right here. So that's where we start, and then we stop right there. So we're moving to the right constant, moving to the left constant. And then notice that my accelerations are all dots. So that means at every point here, we have no acceleration because we have a constant velocity. So all I'm going to put is dots, I'm not going to put arrows. Velocity time graph, since we have a positive constant velocity, and then we have a negative constant velocity, I'm going to just plot a constant positive and then a constant negative. Okay, if both the velocities are constant, then that means acceleration is 0. So everywhere on the graph is 0. So all I'm going to do is just plot 0 right there. Okay, question 2. Same idea, different graph. We have something that's curved up. Now, a description of this is that it is accelerating. So it is gaining velocity, or accelerating to the right, accelerating in the positive direction. I would take all of those as descriptions. Alright, so what will this look like on the motion map? Well, it's going to look like smaller arrows into bigger arrows. Just like this. Those are our velocities. Oops. Alright, so those are our velocities. Then our accelerations are, they're all constant, but what I'm going to do here is I'm going to draw them at each vector. So notice how the acceleration vectors are spread out, but they're all the same length, and that is showing that the acceleration is constant the whole time. Okay, so our velocity time graph will look like this. So our velocity is increasing as time goes on. And it is a constant. So we're going to have a constant positive slope. If it is a constant positive slope, that means we're going to plot a constant. So the acceleration for this little section here is just a constant positive, and that's it. So that is our acceleration graph. Alright, moving on. Number 4, it is curving down, so it's a little bit different. So let's describe what's going on here. The slope is decreasing, so that means the velocity is decreasing, or in other words, it's slowing down. Alright, so we're moving at a positive velocity, and we are slowing down. So we have a negative acceleration here. Okay. So here's our motion map here. We have velocities that are decreasing. So bigger vectors for velocity and then into smaller ones. But our acceleration, since we're slowing down, it's actually going to point to the left because it's trying to slow us down in the motion. Right, so acceleration is negative, velocity is positive. Here's our graph. Velocity is decreasing as time goes on, so we'll have a negative slope. Now, at this point, you might catch on to the pattern. If we got a negative slope for velocity, then we will have a negative constant for acceleration. Alright, so everything is going to be related to each other. Alright, I'm going to breeze through the rest of these because I think you'll see the patterns now if you are carefully looking at what I'm doing here. So, number 6 is it's curving up and then it stays constant. So what that means is we're accelerating and then we're moving at a constant velocity. So we're accelerating in the positive direction and then we move at a constant velocity. And that is also to the right, and all are positive. So motion map here, let me go back so you can see each part. Okay, so if you look at, I tried to draw this the best I could. So we have small vectors that go into bigger ones, and then they're the same, so that means it's going to be constant. Alright, the bell's ringing and 7th period's about to start, so tune in for part 2 to hear the rest.